Now let's see this question. An interesting one. It seems there's an election with only two candidates contesting, and we have the information about how many people did not vote, how many votes were considered invalid, and how many votes were secured by the winner and loser. Using all this data, we have to find the total number of voters in the list. Now, if I assume the total number of voters in the list is n, now 15% of the voters did not turn up for the vote. So I can say the number of votes that were cast is 85% of n, out of which 50 votes were considered invalid. So I can say the number of votes which are valid is 85% of n minus 50. And these are the number of votes that the winner and the loser together have got. It seems the winner has got 44% of the votes and the loser has got 200 votes less than the winner. So if the winner has got 44% of n as the number of votes, then the person who has lost the election would have got 44% of n minus 200. So 85% of n minus 50 is equal to 88% of n minus 200. So as you can see, the difference is 3% of n, which is equal to a difference of 250, that is 150 votes. Now, if 3% is equal to 150, we know 100% will be equal to 5,000. Hence, the total number of voters in the voting list is equal to 5,000. Now, let's see this question. An interesting one. There is an XY plane and 2 points AB minus 2 comma 0 and 2 comma 0. Now, we need to find the set S as a collection of all points C on the circle x square plus y square is equal to 4, such that the area of the triangle ABC is an integer. Now, the number of points in the set S is. Now, there are multiple conditions. So, let us take one after the other. Now, there is an XY plane. So, let me draw an XY plane with 2 points, A minus 2 comma 0 and B 2 comma 0. Now I want to find the third point C such that ABC form a triangle. But what are the type of points that I want to consider? The third point that I take should satisfy two conditions. Number one, the area of the triangle formed by ABC must be an integer. And number two, the point must lie on the circle x square plus y square is equal to 4. Now, when I take the circle x square plus y square is equal to 4, it is clearly seen that it's a circle with the center as origin and the radius as 2. So if I draw the circle with center as origin and radius as 2, then this will be something like this, passing through minus 2 comma 0 and 2 comma 0. Now, any point I take on the circle as C, for example, suppose if I say this is point C, right? And since the radius is 2, we know this is 0 comma 2. And of course, diametrically opposite will be point D or another point C, which is 0 comma minus 2. Now, if I take 0 comma 2 as the point C, how do we calculate the area? We know the area of a triangle. Area of triangle ABC is equal to half into base into height. Now, the base is the line AB. So, minus 2 comma 0 to 2 comma 0, the distance is 4 into h. So, which means the area is equal to 2 into height. And since I want the area to be an integer, it means h must be either integer or multiple of 0.5. So if it is a multiple of 0.5, since I have 2 into h, the result will definitely be an integer. Also, if you observe, guys, suppose if I take a point C here. Now the height is simply calculated as this vertical line. Now suppose if I take another point C here, this is how the height is calculated. So for every point on the circle, the height is nothing but the y coordinate. So I need to look for points on the circle such that the coordinate of y for each of those points must be either an integer or a multiple of 0.5. So for example, if I say y is equal to 0.5, then substituting it in x square plus y square is equal to 4, we get the value of x as square root of 4 minus y square. So which is equal to square root of 4 minus 1 by 4 or plus or minus square root of 3.75. So similarly, the value of y can be 1. The value of y can be 1.5. So in each case, I get x is equal to plus or minus square root of 3 and x is equal to plus or minus square root of. Now 1.5 is 3 by 2. So square of 3 by 2 is 9 by 4. So 4 minus 9 by 4, or rather you can say 1.5 square is 2.25. So 4 minus 2.25 is plus or minus root of 1.75. So as you can see here, for each value of y, I have two values of x. So which means I could gather 6 points here. However, the height need not be only on the right side of the y-axis. It can be on the left side of the y-axis as well, which means the value of y can be minus 0.5, minus 1, and minus 1.5 as well, which gives you 6 more points. So 6 plus 6, we have 12 values as of now. Now, the last value that we can take is y is equal to 2 or minus 2. If I consider y is equal to 2 or minus 2, in both the cases, x is 0. So this gives us 2 more points. Hence, the total number of points in the set S that we are looking for, which satisfies all the conditions given, is 14. Now let's look at the sixth question. The length of the line segment joining the two intersection points on the curves given is. Now let us find out what are the points of intersection. Then it will be easy for us to find the distance between those 2 points. Now it is given that y is equal to 4970 minus mod x and y is equal to x square. So if I equate these two, or in order to equate these two, I will say y is equal to x square can also be written as y is equal to mod x whole square. So then equating these two, we get 4970 minus mod x is equal to mod x whole square. So which becomes mod x whole square plus mod x minus 4970 is equal to 0. Now we need to find two numbers whose product is equal to minus 4970, but whose sum is equal to plus 1. Now, if you factorize 4970, you will see that it is equal to now 7 into 7, or hold on. I think we can write it as 4970 is 70 into 71. Yes. Now, since I want their sum to be +1, I will take the smaller value as negative and the larger value as positive. So I can write it as mod x square minus 70 into mod x plus 71 into mod x minus 4970 equal to 0, which can be written as mod x minus 70 into mod x minus 71 equal to 0. Thereby, the value of mod x can be either 70 or mod 70 or 71. So if I take mod x as 70 or mod x as minus 71, it is very clear that the mod of a number cannot be negative. So which means mod x cannot be equal to minus 71. And if mod x is equal to 70, it means x can be either plus 70 or minus 70. Now let us find the corresponding values of y so that we can determine the points of intersection. So if I take x is equal to 70, then y is equal to 70 square. And if x is equal to minus 70, even then I can say y is equal to 70 square, because minus 70 whole square is same as 70 square. So the points of intersection are 70 and 70 square, followed by minus 70 and 70 square. Now the finding the distance or the length of the line segment joining these 2 points, applying the distance formula, we get square root of 70 minus of minus 70 whole square plus 70 square minus 70 square whole square, which becomes square root of 140 square plus 0. So hence the length of the line segment joining the points of intersection of the given curves is nothing but 140.